welcome to Javaism, and in this video we are going to talk about concurrent collections. Okay, and also we can understood why concurrent collections will came, what is the problems with having our existing collections, and what is the advantage, what is the disadvantage, and how we can do work with the concurrent collections we can discuss in this video. So let's start now. So first we need to understood what is the concurrent collections, and then after one by one I explain each and everything. Okay, so basically concurrent collection is nothing but is also known as a concurrent data structures. Okay, so whatever the collections we have, those are a part of the data structures only. So concurrent collection is also a part of the data structures, are a type of the data structure designed to be a safely used. This is the very important line, safely used by the multiple thread or process in a concurrent or parallel programming environment. Because right now whatever the collections we have, like a hash table, vector, those are thread safe, that is fine, no issue in that. But the performance of the vector and hash table is very low. Okay, because they will block or lock the entire collections for the one thread. Only one thread can access, and they will perform whatever the operations they are performing. Then only you can do and allow the other thread to do the operations. Okay, so because of that our hash tables and vector is very slow in the multiple thread environment. It's a thread safe, no in doubt. But if you go with the concurrent collections, it's a very good experience. You can see in the multiple threads also, multiple environment also, and the performance is good. Okay, in such environment, multiple threads or processor might be accessing and modifying the shared data. Okay, so for example, whatever I have a vectors or whatever the linked list or whatever the hash map or hash tables we have, so at the same time, if multiple thread are trying to modify the data, some have tried to modify, some have tried to add, delete, or some have tried to fetch the data, some have tried to remove the data, lots of the operations we can perform. Okay, so in that case it's a very secure and it's a very thread safe. If you go with the concurrent collections, you can't get any concurrent modification exceptions. So if you see, lots of the interviewer ask you, hey, do you know why we are getting the concurrent modification exception and how we can resolve it, what is the issue of that? Okay, how we can reproduce those issues? Might be lots of the questions they will ask regarding the concurrent modification exceptions. So all those things I am going to cover in this video. Okay, let's understand one by one each and every point very clearly. Okay, so in the multiple environment, thread processor might be accessing or modifying the shared data simultaneously. Okay, which can lead to the issue like a data corruptions, race conditions, and inconsistent behavior. Okay, in our existing collections. Okay, but concurrent collections are specifically designed to handle those situations. Whatever the situations I told you, which is race condition, data corruptions, inconsistent behavior, those all problems will solve our concurrent collections, are specifically designed for the handle these situations and provide the thread safe access to the data. Thread safe means what? It's a thread safe so that multiple thread will not access at the same point of the data. Okay, that is called thread safe. Okay, let's go forward to the 4th point. In Java, the java.util.concurrent package provides a various thread safe. Okay, so this package is available in 1.5 only, I think, and no 1.5 having a lots of the improvement, 1.2 only it's came. Okay, so package provides the various thread safe collections classes that they are designed for the concurrent programming. Concurrent programming. Concurrent programming means whatever the threads you have, you can do the operations, it will give the better performance, those things. Okay. These classes ensure that multiple threads can safely access and modify the collections without cause data corruption or synchronization issue. Here is the some example commonly use the thread safe collection classes for the package. Okay. So while handling a thread safe for the collections or might be whatever the collections we have, okay, we are using the synchronize keyword to block some methods or some of the synchronized block we can create a synchronized method we can make. Through that also we are trying to protect our whatever the executions we are doing as a thread safe, right? Let's go forward and try to understand what is the concurrent collections and how it will work. So we can start with one problem. Whatever the existing problems having in our map or collections we can discuss, and then after we can go to the next and we can understand. So let's understand like how we can reproduce, how we can produce the concurrent modification exception with the help of this program. So these programs I have given you for your reference so that you can try these programs, and with the help of that one you can reproduce your concurrent modification exception. Let me explain you. So this is the one class we have created, concurrent modification example, and we have created one map which is hash map, and inside this map we have added three value 1 2 3, okay, in the map, and then after we have created a thread to modify the hash map while iterating. We have created one thread, okay, and directly we have implemented the runnable method here with the help of the lambda expressions directly, and then after we have used the iterator, and with the help of the iterator we have taken all those key and we have created the iterator, and then after we are iterating it, and while iterating in this line hash map dot put we are printing the data also, and we are adding some data also. So if you are getting some data and we are printing, that is fine, but at the same time you are adding a data inside this map which is hash map, so that time you can get concurrent modification problem exception. Okay, why? Because this iterator is what is doing, it's iterating. While iterating only they have only three data 1 2 3, but after one iteration he see now this having a 4 data while putting this data, so he will say no, it's not accepted because you I have already assumed, iterator is already assumed only 3 data I will print, but at the end they are saying like we have a one more data and you have to print it also. That time he confused and he will give concurrent modification exception because of iterator. Okay, let me show you. So what I'm going to do is I'm going to create quickly one program here, okay, and I'm going to create one class. So let me create one class. Okay, so first I'm going to create a class and I will show you the collection example, then after map example, everything, and I will reproduce the concurrent modification exceptions. Okay, and in this class let's take the list, okay, list concurrent, list concurrent, CONCURRENT test example you can say. So I have created one class here, you can see, and inside this class I'm going to create one main method, possible, no issue. In this class I'm going to create one list having a list of the data. So let's take some string, and string will be list equal to new array list I'm going to take, and with the help of array list array list I am going to store some of the data. Okay, So what I'm going to do is I'm going to store some of the name of the users, okay, inside the array list. So I don't want to create a object, okay, I can directly assign also, but let me put first, okay. So what I have done is I have a list of the data, so I'm going to add some of the data. List dot add. Here I will add Anuj, okay. In the next line, Control Alt arrow down, and here I will add Deepak, and here I will add Ajit. Okay, those are my friend name, Anuj, Deepak, Ajit. Okay, I have added here. Okay, now what I am doing is I am going to create one thread. So this data added by whom, which is main thread. Okay, I hope you already understood the thread concept, so I'm going to teach you. So this data will added by whom, which is main thread. Now I am going to create one more thread, and through that thread we are going to iterate the collections. Okay, otherwise directly also we can do inside the main method, that is also possible, but let's create one more thread. So how we can create a thread? So we have a one thread class, so thread new equal to new thread, and inside the thread we have to provide the implementations of the runnable. So we can take the runnables help, and here with the help of the lambda expressions, I hope you know, with the help of the lambda expressions we can provide the implementations of whom, run methods. Okay, and here you can give the semicolon, it's a one line of the code, done. And then after, what can I do? I can create one iterator. Okay, iterator, I want iterator, java.util iterator, and iterator will store a string type of the data. Okay, whatever the data we have in the list, those data this will also store. Iterator equal to, what we can do, we have a list, so list dot iterator, so it will give one iterator. What I am doing is, with the help of the iterators I am going to iterate all those data. So we can take while loop, okay, and with the help of while loop we can write iterators, okay, dot hash next, we have a methods, and with the hash next it will say like, okay, data is available or not, okay, and if it is available, the while is true, then we can go inside this, and what we can do, we can do s out, and in the s out what I'm going to do is I'm going to write what, iterator dot next, so it will give me the value, and we can print it also. Along with, I'm going to add one value, add one value in list while iterating only. So what I'm doing is, with the other thread I'm trying to add some value, correct? Let me add. So we have a list dot add, and here I'm going to write my name Prince, and this value I'm trying to add inside the list, that's it. Okay, after that once it is done, what we can do, we can start this thread, okay, which is thread new dot start. Once we call the start method, automatically it will call the run method internally, and at the end we can join the thread both, like whatever the main thread have entered the data and whatever the new thread have entered the data, both thread will join, then only we can end our application. So for that we can try to join directly, so we have to create for that try catch. So this is the catch, and it will handle the exceptions. Okay, let me leave it blank, and here what I'm going to do is I'm writing thread new dot join. So it will join the main thread, then only we are going to end it. It's a optional part, you can skip it also, you can write it also, no issue. Okay, once you run this thread, not thread, it's an application, what I am getting, a node is printed, and after that I got one exception, concurrent modification exceptions. Correct or not? Correct. What is the exceptions? Concurrent modifications exceptions. Concurrent modification exception, which is available in the java.util. Okay, what is the exception is in the thread 0. Okay, checked for co-modifications, right? So this is the one way to reproduce concurrent modification exceptions. Okay, let me write directly without creating any thread or anything. I'm going to write each and everything inside the main methods. Okay, I don't want to start the thread, I don't want to do anything here also, I don't want this one also, I don't want this one also. Okay, let me format it and let me save it. Okay, now directly I have created the thread and I am adding it. Okay, let me run one more times. Okay, what I'm doing, I'm running one more times and I have added the prints. Okay, let me minimize these screens and let me run once again. So once I run it here, in that case also we are getting what? Concurrent modification exception. It means it should be one thread or two thread, whatever, you can get concurrent modification exceptions. Okay, if you try to modify some of the collection at the same time while iterating a data. Okay, correct? Yeah, correct. So this is the way. If you are trying to reproduce in the map, you can do the same thing which I have given here. Okay, you can create one map and inside this map you can try to modify with the help of the new thread, or you can try to add, that time you can get. Let me do that code also so that you can understand in a better way. Let me show you the example of map also, like how we can create a concurrent modification exceptions with the help of the map also. So I'm going to create one class which is called concurrent. Okay, let's take map concurrent, Concurrent concurrent exceptions. That examples I have given. Okay, in this class what we have to do is we have to create one main methods. Okay, once you create the main method, let's take one example of map. So I'm going to create one map, and map should contain the key and value. So I'm going to take both are a string, and make sure take the example of the strings only, because sometimes with the help of the integer, if you take key as a integer, then sometime it will not support also. Okay, and you can't see the concurrent modification exceptions. So make sure take the something which is reference type of the data type, it will support it. And here also strings, and I will take map equal to new hash map. Okay, quickly I have cleared it, and what I'm going to do is I have put some data. So map dot put. Okay, here I can say 1, and I will put the some name of the friends or something. So let me take the example of Apple, or maybe I will give the name which is my name only, and here I will give the semicolon. Control Alt arrow down, 3 items I will add it inside the map. Let me give the 2, and here I will give the 3. I will change the name Ajit and Sujit, anything. Okay, clear? Next what I have to do is I will take the help of some other thread also, and in the same thread, which is the main thread, we can do the operations, but it's your choice. But let make me simple. So what I'm going to do is I'm going to create the map. So what are the map we have? With the help of the key set, we can take the set, and through that I will create one iterators. Okay, so let me create one iterator, and iterator will assign the value, and then after I will try to iterate, and I will try to put some data also inside this. So what I will do is I will write here while loop, while, and while iterations has more next element. Here also you can do like that, but I don't want to do like that. What I'm going to do is concurrent modification exceptions. What we will do, we have to resolve this issue. So how can I resolve this issue? Simple, change this map with the help of concurrent has map. Okay, concurrent has map. Okay, so what you have to do is here you also have to write concurrent has map, and here also you have to write concurrent has map. Okay, so once we write the concurrent has map, and again the same code, nothing changes. If I run it, you can see all those values are printed. It's a magic. Okay, so this is the power of concurrent has map, and which is available inside the java.util.concurrent. So that's why we are saying concurrent has map, concurrent modification exceptions. Okay, because of this package name. So inside this package having a lots of the changes, lots of the enhancement, lots of the modifications, they are coming come inside the 1.8, 1.5 also. Okay, and that is very useful for the multi-thread. Okay, so whatever the issue we are facing, those it's resolved here, and we are able to print 4 data also, no issue in that. So that is the powerful concept of the concurrent modifications, and I hope you guys understood what is the difference between concurrent modifications and what is the difference between why we are getting the concurrent modifications in the list, array and map. I hope with the help of this example you understood how we can create a scenario like concurrent modification exception with the help of the array list, or also with the help of the hash map, and how we can resolve it with the help of the concurrent hash map and concurrent hash map. Concurrent having lots of the classes, with the help of that we can resolve a array list issue also. Okay, so let's see one by one how we can perform well using a concurrent package. Okay, so I hope you understood this example, and with the help of this example we are going to understand what exactly we are doing. So in this example, a separate thread, modified thread, is created, which we can see here. Okay, and this thread is going to iterate your hash map, and corresponding it will add the one value which is 4 concurrently. So running this code might result in concurrent modification exception being thrown, because the modified thread is the hash map, while the iterator is iterating over it, the violates the accepted behaviors of the iterators and cause the exception. To handle the concurrent modification safely, you should use the thread safe data structures like concurrent hash map from java.util.concurrent package, and synchronize access to the hash map using a proper synchronization mechanism so that you can achieve it. Okay, and we have discussed also like how we can handle it. Let's go to the next slide, and here we are going to understand what is the hash map, what is the overcome the hash map problem with the hash tables. So basically, if I talk about a hash map, okay, so this is the hash map, and hash map having two threads, and they are executing the hash map. So they are able to execute, no issue in that. They are able to execute it, no issue in that. But only condition is, in some point of the time, the one thread is try to modify and other thread is try to what? Iterate the value. In that situation, you got or we got concurrent modification issue in the hash map. while iterating a two thread or one thread, whatever. And also, so because of that we can say it's not a thread safe, can have one null key and multiple null value, that is also possible. So one null key you can put inside the hash map and multiple null value you can put, no issue in that. Okay, so multiple thread, if one thread is iterating the value, another thread is like adding the value, in that situation your hash map will not work properly. It will give data inconsistent problems or concurrent modification exception, just before we have seen. After that, to overcome these problems, we have come up with the hash table. What about hash table? So hash table is providing a access of particular hash table one by one thread. Two thread directly will not operate entire hash table. Okay, so one by one thread will operate it. So if one thread is doing work something, the other thread have to stop and waiting a stage. Once thread is completed, then only other thread will do the operation. It's a thread safe because one by one thread is coming and executing those data. Slow performance because of other thread is waiting, and null key and null value are not allowed in the hash table. This is the difference between hash map and hash table. Then again we are coming with the synchronized map. After hash table we have come up with the synchronized map. Synchronized map will resolve some problem, it will also the same behavior like a hash table, only one thread can access and other thread can waiting a stage. It's a thread safe and slow performance. It will null key and multiple null value are not allowed. Null key and multiple null value are not allowed. So one null key and one null value it will accept, it will not allow multiple null value. That is the situation having a synchronized map. Clear? After that, so hash map, hash table, synchronized map having a only the genuine problem is like performance. Okay, so performance wise this hash table and synchronized map is not good. Hash map is good, but when multiple threads are working, that time it will data consistent or thread safe issue will come. Okay, but to overcome all those problems, we have come up with the concurrent hash map. Which map? Concurrent hash map. Concurrent hash map, what they is doing internally is, we have a one hash map we have created. So by default, whatever the hash map we have created, which is by default 16, you can give your own size of the hash map, default size, or your own size, what is the load balancer, you can give your own. So those things you can manage based on your requirement, but generally the default conditions we are discussing here. So what they will do is, if the multiple thread are working on the concurrent hash map, so thread 3 is waiting on the same segment thread 1. So for example, this will concurrent hash map will divided every block in one segment, every block in one segment. If in one segment or one block, if one thread is doing operation, then other thread will wait. Otherwise, if other thread want to do some other operation in other segment, they will do. Not issue at all. So thread 2 is parallelly doing work in this index or in this segment. Parallelly thread 1 is doing work in this segment, but in the same segment, if third thread is also came and try to do the work, then it should have to wait. Okay, so multiple thread reading the threads possible at the same times, 1 2 3 4 5, whatever the threads you have, they will read the data at the same time, no issue in that. So one problem they have resolved, it will divided in the segment, and segment means every cell of the hash map. Okay, so it's divided in the cell, and whatever the data you store, it's not block entire hash map. Okay, it will only block the segment. If you see here, the thread or hash table or synchronized map, they are blocking the entire synchronized map or entire hash table. to access some other thread. But in this situation, the other thread, so you can say if you created any concurrent hash map, so by default at the same time 16 thread will work parallelly in the different segment, right? But so because of that, what will happen, your performance will increment by default, right? If the 16 threads are allowed to do the work parallelly, definitely the performance will increase. But here if you think, in that case hash table or synchronized hash map, they will not allow all the segment, they will not divide it in the segment, they will block entire object. So because of that, performance is slow. Here you can see performance is fast, null key and value are not allowed. Okay, that is the same only case or scenario. Okay, so this is also a same, but they have lock, the locking system is based on the segment they have divided, and because of that they have improved the performance. Okay, I hope you understood. Okay, you can explore more, you can understood more about it. Let me go to the next slide. So in this slide I want to explain you like what is the current hash map and how it will work. So map is a parent extended by the current map, and current map extends by the concurrent navigable map, and concurrent navigable map implemented by the concurrent hash map or concurrent escape list map. Okay, and those are the hierarchy of concurrent map you can see. So these are the two interface. Map or concurrent map is a interface, but concurrent hash map and concurrent escape list map is a what, it's a classes, so we can use those classes, correct? Clear? Here if you see, if you talk about the collection which is list, set, so queue or blocking queue, so in that scenario there is lots of the enhancement will happen inside the java.utility.concurrent package, and they have come up with the lots of the classes which is concurrent escape list set, copy on write array set, concurrent linked queue, synchronous queues, array blocking queue, delay queue, link blocking queue, priority blocking queue, link transfer queue, link blocking queue. It's a lots of the classes they have given to handle the multiple thread at the same time, and with the help of that classes we can improve our performance of our code too much. And of course the every project having a lots of the like multi-threading we are running, and multi-threading we are doing work on that. So in that case, if you are facing the performance issue, you can take any of the classes and you can do the work on that. Okay, so this is the part of the set, you can see directly it's a part of the set. And if you see the list, so copy write on array list, this is also a class, copy on write array list. So with the help of that you can access the random access, clonable, serializables, all those things you can maintain with that classes. Okay, if you want concurrent link queue to maintain the queue functionality, you can take this one, it will also give the better performance in the multiple environment, a multiple threaded environment. Okay, so the popular thing is inside this diagram you can say copy on write array list, you have to practice. Concurrent escape list set is also very important. Concurrent linked queue is also very important, you have to practice. And priority queue, blocking queue is also very important. So do the practice on that. Copy on write array list. So I am going to explain you one. You can practice other. It's the same thing only, nothing difference. Only it will give the better performance if you select any of them. Okay, and might be the after some years people will ask, interviewer will ask those questions only, not like what is the set, what is the list differences, and what is the implemented classes. They will talk about this concurrent implemented classes, so you have to ready for that also. Okay, let me go and write a code for the copy. Okay, so I'm going to resolve one problem which is we are facing inside the list. Okay, so list issue multiple thread. Okay, so this is the list issue. What I'm going to do is I'm going to create one main methods. Okay, and inside the main method I will create one new copy on array list, copy on write array list. So this is also a list. What they will return, let's see. They will return one list only, which is copy on write list. Let me store this as a list. Okay, and what I'm going to do is I will not store here object, I will store some string data. Okay, and in the same case what I'm going to do is I'm going to store some of the data inside this. Okay, so how can I do it? Same way, copy list dot add method I can use, and I can store Ajit. Okay, in the same way I can copy this line, control alt arrow down, and I will change the name here super and duper. Okay, and what I can do is I can just write a one iterators, or otherwise I can create another thread. So let me create another thread. Okay, t equal to new thread. Directly we are going to implement the runnables inside this. So take the help of the lambda expressions and create one class. Let me give the semicolon here. And here what I'm going to do is I'm going to create one iterator with the help of copy write array list iterators, and those iterators I will store it, and after that I will iterate with the help of while loop. Okay, and I will write iterator dot hash next. Okay, and I will write iterators dot next, and through that we can read the object, but while reading an object we need to print also. So let me write this out. Okay, and I will give this data, and along with while iterating also I want to add some of the data in the copy on write array list dot add. Okay, and what I will add? I will add 1, and in the same way I will add 2 also. So this is the 2 data I am going to add. Clear? And at the latest I'm going to start this thread t dot start. So once I will start, okay, and let me show you the console also parallelly. So let me remove everything and let me run this code. Run. So it's printed 1 Prince, Ajit, Sujit, Raju. That is the different code here. Okay, that is the different code. Okay, Ajit, super duper. This is the 3 data it's printed, but if you see the size, of copy dot list, what? Just expect what is the size. So size is 5. Oh my god, it's a 3. How it's a 3? Because Ajit super duper, it's 3 only as of now. So what I'm going to do is at the end I want to print s out all those data I want to print. What is the data are available inside this? It's printed 1, 2, 3, only 3 data. Why? Because this thread is running, okay, and it's already printed 3 is available, that is fine. And once you start, that time only 3 is available, so 3 will be printed, 3 is printed. Ajit super duper, it's printed, that is fine. As of now, whatever they are doing before running this thread, it's printed, because main method will do parallel work and this thread will do the parallel work. Okay, so before printing this issue, they are printing first this one, and then after once they will run, they are printing this one. So what we can do is, how we can make it consistent? So for that we have to write join. Okay, and we can write here t dot join. Once it is joined, then only you have to go further. So we are joining the both the threads. Okay, let me run again one more times. Okay, now if you see, what is the value? Ajit, super duper, and now size is 9. How size is 9? How size is 9? Just assume what we have done. We have put these two lines inside the loop. So if it is executed 3 times, so 3, if it is executed 3 times, so 3 to 6, and this is the 6 time added, and this is the 3 times. So 6 3 9, size will be 9, and they have printed all those data 9 times. If you are able to see 1 2 1 2 1 2, it's the 6 time it's added. I don't want to, I will remove it. Now how many times? 6 times. Correct? 6 times. And join, what will do join? Join will say hey main and hey thread t1 t. Once you completed both, then you can join, and then after you can go further. Don't go fast. Okay, and because of that we are getting the correct answers here. Okay, and we are not get any concurrent modification exceptions also, guys, make it sure. Okay, so this is the power of copy on write array list, which is available in concurrent package. In the same way, this is the problems we have solved of the list, array list. In the same way, you can solve the problems of hash map. With the help of the hash map also I will show you. Concurrent hash map we have used, and with the help of this use we have get the data. Okay, right, this data without concurrent modification exception. So hash map problem will solve by the concurrent hash map, and list and whatever the set we have, those problem will solve by the copy on write array list, those classes. I hope guys you understood how it will work and how data will store, how we are writing the join, each and everything. Let's go to the slide and try to understand. Okay, so they have given some of the classes which is very important. Concurrent hash map is a thread safe alternative to the hash map. It support a concurrent thread and read and write operations efficiently by dividing the map into the segment with the separate lots. Concurrent link queue, a thread safe implementations of the link queue suitable for the concurrent producer consumer scenario. Okay, so when you are using the Kafka or when you are using the RabbitMQ, that time it's very important. Concurrent link queue, it's a thread safe double queue having a double ended queue, and you can do the work on that. Link blocking queue, array blocking queue, priority blocking queue, copy on write array list. It's a very important. I will show you just before. Copy on write array set, concurrent escape list and concurrent escape list map. Concurrent escape list map, you can try to use all those things. It's a very important. Okay, a thread safe view of the key of the concurrent hash map, opening a thread safe of the set of the key without copying the key into the new data structures. Okay, so go and try to explore all those things, because if I do each and every code in front of you in the Eclipse, might be not understood exactly, but if you do your own, if you write these classes, just replace my classes with your classes, these classes, and do the work, no issue. Okay, these classes provide a various synchronization mechanism to ensure thread safety. However, it's important to choose a appropriate collection classes based on your specific requirement. So this is the details I have given. So based on that, you can choose when where you want to use this particular hash map. Okay, keep in mind that while these collections provide a thread safety for the basic operation, you should still design your application logic carefully to avoid more complex concurrency issue. So in the some of the times, like if you scale your project, if you do something very big level, that time maybe they will give the issue, but you have to keep in mind to design your project in the better way so that it will always be thread safe. Okay, so this is the solutions of the map list whatever we have. So they have created one concurrent hash map, and a string integer they have stored with the help of the concurrent hash map, and here they have created three thread write thread 1, thread 2 write thread 2, thread 3 write thread 3, and they are fetching the element here, they are adding also with the help of the loop. Okay, so that time also they are not getting any thread safe exception. What they are doing, I will show you. Okay, so I have already given you solutions, but still one more times. Okay, what they are doing is like we are doing these operations. Okay, so not directly, what we have to do is we have to do these operations but inside the thread. So create one thread t1, otherwise you can write 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 thread 1 equal to new thread, and provide the runnable. Let me give the same, no, just provide the runnable. So run methods, not run methods, you just have to give the lambda expressions, and inside the lambda expressions you can create it. And this is the one thread, right? And you have to start this thread, at the end we can start, and we have a other thread also, they are adding some data. Okay, so let me give, this is the read thread, basically we are iterating the data and we are putting it. So this is the read thread, read thread 1, write thread 1, and here they are not writing anything, so we don't want iterators. So what we can do, we don't want anything, we can directly add the data. So inside the map we are adding these three data. Let me add two data here. Okay, and this should be 10, 20, A, and this should be B. For your understanding I am giving. And one more thread I will create. Okay, so this is the thread 2 which is going to also write. Here we can write 100, 200, and here AA, BB. Okay, and finally here we are going to start all those threads. So what I'm going to do is write thread 1 dot start. Okay, write 2 thread dot start. So they will also write it inside this, and third thread is read thread dot start. So at the same time 3 thread will be started, and they will, once you have started all those thread, your issue will be resolved. So let me run once again. So once I run it, you can see the output. Like first time 1 is Prince, 100 is AA, the third loop Ajit, 200 BB, Soijit. So concurrently you can say at the same time all those threads, like almostly I have created writable thread is 1, 2, 3. So 3 is the thread which we have created, and 1 is main thread which is inserted this data. All are printing. Okay, and they have started writing a code also, and once it is printed we are getting output here. Okay, let me run one more times. So once I run, you are able to see the output here. Okay, so first what they have given, they have given 1. Okay, 1, again other loop will be iterated, which is second loop, and it's added some value, third value, all those value, and once it is added, simultaneously at the same time we are able to print and we are able to take all those data and he is able to iterate it. That is the power of hash map. Okay, so in the multi-thread environment, like we have created the 3 thread here. Okay, in the multi-thread environment also you can do the operations with the help of concurrent hash map, and also performance is very good. Okay, let's go to the slide. Okay, so this example I hope you understood, guys. If you want to join and then you have to go further, so you can write try and you can join all those thread and then you can proceed with the main methods. Let's understand. In this example we have a concurrent hash map, right, named called concurrent map. We have created a writer thread which is 2 thread and that concurrently inserted the key value pairs into the map, and a reader thread we have one, and reader thread is reading the value from the map. Since concurrent thread hash map is designed to handle the since concurrent hash map is designed to handle the concurrent read and write operations. Since concurrent hash map is designed to handle the concurrent read and write operations, you can see that the thread can safely access and modify the map without explicit synchronization. The concurrent hash map ensures that the data remains consistent and that there is no data corruptions or race conditions issue. Remember that while concurrent collections handle the basic concurrency scenario, more complex synchronizations and coordinations might be needed for the more initiate scenario in your application. So based on that you have to take and you have to design it. Okay, let's quick understand what is the thread safe and what all things. So just comparison between the hash map and concurrent hash map. So in the hash map, if you see, synchronize internally not, but concurrent hash map we have based on the segment or particular indexes, we can say. Thread safe in the hash map no, but in concurrent hash map we have, so that multiple thread can do the operations. Okay, introduced in JDK 1.2 hash map, but JDK 1.5 it introduced the concurrent hash map. Package java.utils available the hash map, java.util.concurrent it's available the concurrent hash map. Null key allow hash map, null value allow hash map, but concurrent hash map will not allow any null key and null value. Nature of the iterations, the hash map is a fail fast. Whenever the multiple threads are doing the operations on the hash map, it will fail fast, like immediately it will give the exceptions and it will say concurrent modifications exceptions. Okay, but in the concurrent hash map we have a fail safe. We can't get any exceptions like a concurrent modifications exception, that is called a fail safe. Fast or slow hash map, obviously it's a fast. Okay, for the reading a data from the hash map and without we can say multiple thread can read the data, so in that scenario it's a fast, but multiple environment it's not a good. Okay, and concurrent hash map little bit slow compared to the hash map. Okay, because it's internally maintain the thread safe. Okay, synchronization concept. Where to use single threaded application, you can use the hash map, but multiple threaded application you can use the concurrent hash map. I hope guys you understood what is the concurrent, what is the concurrency, what is the concurrent package, what is how to get concurrent modification exception, how we can resolve it with the help of concurrent hash map, copy on write, array list. Okay, so I have discussed those 2 classes and those are very important, and we have discussed each and everything. So thank you so much. Okay.